The directions say to determine whether the given series converges or diverges. So the main theme in these examples is applying the ratio test. So let's take a look at example 1. Suppose we have the summation from n equal 1 to infinity of n over 5 to the n. A sub n is equal to n over 5 to the n. A sub n plus 1 can be found by replacing n with n plus 1. So we get n plus 1 over 5 to the n plus 1, which is equal to n plus 1 divided by 5 to the n times 5. So the absolute value of a sub n plus 1 over a sub n is equal to the absolute value of n plus 1 divided by 5 to the n times 5, all over n over 5 to the n. Okay? Now, we can get rid of those absolute values, and we can write this as n plus 1 divided by 5 to the n times 5 times 5 to the n over n. So notice when you divide by a fraction, right, if we take a numerator and divide by a denominator that's a fraction, we can take this numerator and multiply by the reciprocal of the denominator. So in other words, we can multiply this by 3 over 1. So that's why I'm taking n plus 1 over 5 to the n times 5 and multiplying by the reciprocal of the denominator, which is 5 to the n over n. And so 5 to the n's cancel, and we're going to get n plus 1 over 5n. Now, let's look at the limit as n goes to infinity of n plus 1 over 5n. And for this next line, you might notice I'm splitting the fraction. So I can write this as the limit as n goes to infinity of 1/5 plus 1 over 5n. And so, again, I just use this property down below. But as n goes to infinity, 1 over 5n goes to 0. So this is 1/5, which is less than 1. And so that tells me that the series from n equal 1 to infinity of n over 5 to the n converges by the ratio test. Let's take a look at number 2. Suppose we have the summation from n equal 1 to infinity of negative 1 to the n minus 1 times 3 to the n divided by 2 to the n times n to the third. So a sub n is negative 1 to the n minus 1 times 3 to the n divided by 2 to the n times n to the third. So a sub n plus 1 can be found again by replacing the n with n plus 1. So when we do that, we get negative 1 to the n times 3 to the n plus 1 divided by 2 to the n plus 1 times n plus 1 to the third. So notice up here, this n became n plus 1, and n plus 1 minus 1 equals n. That's where I'm getting negative 1 to the n. So when I simplify this, I get negative 1 to the n times 3 to the n times 3 divided by 2 to the n times 2 times n plus 1 to the third. And just like in the first example, I'm going to look at a ratio. So I'm going to look at the absolute value of a sub n plus 1 divided by a sub n. Well, this is the absolute value of negative 1 to the n times 3 to the n times 3 over 2 to the n times 2 times n plus 1 to the third, all divided by a sub n, which is negative 1 to the n minus 1 times 3 to the n divided by 2 to the n times n to the third. So I can write this as, now, before we move forward, let's talk about something here. Remember that the absolute value of negative 1 is 1. The absolute value of negative 1 to the nth power, right? So n could be 1, 2, 3, doesn't matter. This is also equal to 1. And with that in mind, we can strip away those absolute values and just, we don't have to deal with -1 to the n and -1 to the n minus 1 because of these two results. Okay? And so what ends up happening is we get 3 to the n times 3 over 2 to the n times 2 times n plus 1 to the third times, and I'm taking the reciprocal of the denominator, and when I do, I get 2 to the n times n to the third divided by 3 to the n. So notice the 2 to the n's cancel, right? And so do the 3 to the n's. And when you multiply, you get 3n cubed over 2 times n plus 1 to the third. And if you need to, you can write this as 3 halves times n over n plus 1 to the third. Now keep in mind, as n goes to infinity, this piece that I'm circling is going to go to 1. And we can also think about it that way. But we talk about that on the next page. So we can look at the limit as n goes to infinity of 3n cubed over 2 times n plus 1 to the third. This is equal to the limit as n goes to infinity of 3 halves times the quantity n times n over n plus 1 to the third. And this is equal to 3 halves, which is greater than 1. And if you're greater than 1, that's going to tell me that the series from n equal 1 to infinity, right here, of -1 to the n minus 1 times 3 to the n over 2 to the n times n to the third will diverge by the ratio test. So if you get a number greater than 1, we diverge. If we get a number less than 1, we converge. Example 3. Suppose I have the summation from k equal 1 to infinity of 1 over k factorial. Now, let's remind ourselves real quick. If I give you 5 factorial, that exclamation mark is read as factorial. We can write this as 5 times 4 times 3 times 2 times 1, okay? Now, if you look at 4 times 3 times 2 times 1, that's another name for 4 factorial. So I could do that. Okay, and that's what I'm going to apply here. Now, a sub k is 1 over k factorial. A sub k plus 1 is 1 over k plus 1 factorial, but I'm going to strip away that k plus 1 and write the remaining factors as k factorial. So in other words, I'm going to take a sub k plus 1 and write it as 1 over k plus 1 times k factorial. So the absolute value of a sub k plus 1 over a sub k is 1 over k plus 1 times k factorial divided by 1 over k factorial. But we can write this as 1 over k plus 1 times k factorial, okay? And we could times this by k factorial divided by 1. But notice how the k factorials cancel. And so what that tells me is the absolute value of a sub k plus 1 over a sub k is 1 over k plus 1. And if we look at the limit as k goes to infinity of 1 over k plus 1, we get 0. And that's less than 1. And so what that tells me is that the series from k equal 1 to infinity of 1 over k factorial converges by the ratio test. Number 4, suppose we have the summation from k equal 1 to infinity of k over e to the k. A sub k is k over e to the k. A sub k plus 1 is k plus 1 over e to the k plus 1 which is equal to k plus 1 over e to the k times e to the first, if you'd like, okay? But that's what we end up getting. So a sub k plus 1 over a sub k in absolute values is the absolute value of k plus 1 over e to the k times e, all divided by k over e to the k. So we can write the numerator, which is k plus 1 over e to the k times e, and multiply that by the reciprocal of the denominator. So in other words, we're going to multiply that by e to the k divided by k. The e to the k's cancel, and we get k plus 1 over ke. Well, k plus 1 over ke can be written as 1 over e plus 1 over ke. And if we take a look at this limit, we're looking at the limit as k goes to infinity of 1 over e plus 1 over ke. But remember, as k gets large, this second term goes to 0. And so you get 1 over e. Now, don't forget, e is approximately 2.71828, etc. And so 1 over e is smaller than 1. And so that tells me that the summation from k equal 1 to infinity of k over e to the k, that converges by the ratio test. Number 5. Suppose we had the summation from n equal 1 to infinity of 10 to the n over n plus 1 times 4 to the 2n plus 1. Now, I would personally recommend expressing 4 to the 2n plus 1 in a different way. And I claim that you're going to get 4 times 16 to the n. And that's what I did on the second line. And so notice how I told you what a sub n is, and I told you what a sub n plus 1 is. So I wrote that all down. Okay? Now, when I look at the ratio, I end up with, and again, the ratio, let's back up here. I'm looking at the ratio of a sub n plus 1 over a sub n in absolute values. And I get 5 times n plus 1 divided by 8 times n plus 2. And I did all the calculation up here. Now, when I let n go to infinity, again, this is a limit. So in other words, I'm going to look at the limit as n goes to infinity of 5 times n plus 1 divided by 8 times n plus 2. But you end up with 5/8, which is less than 1. And so what that's going to tell me is that the summation from n equal 1 to infinity of 10 to the n over n plus 1 times 4 to the 2n plus 1 converges by the ratio test. Okay, let's look at this last example. Suppose we had the summation from n equal 1 to infinity of 2 times 4 times 6 times 8 all the way up to 2n divided by n factorial. This is a really, really good question. Okay? My a sub n is 2 times 4 times 6 all the way up to 2n divided by n factorial. Now, a sub n plus 1 is 2 times 4 times 6 times ... times 2n times 2n plus 2 over n plus 1 factorial. But we can write this as 2 times 4 times 6 times ... times 2n times 2n plus 2 over n plus 1 times n factorial. And you might wonder what happened here. So if you look at a sub n plus 1, okay, remember that I'm replacing n with n plus 1. And just as a side note, 2 times n plus 1 is 2n plus 2, okay? So when you write these factors down, you get 2 times 4 times 6 times, again, you continue in that pattern till you get to 2n plus 2. So every factor is accounted for up to this value, but that means the one before it is there too. In other words, 2n is also included. And then we end up dividing by n plus 1 factorial. And that's what I end up with down here. When we look at the ratio, right? In other words, when we look at the ratio of a sub n plus 1 over a sub n in absolute values, we get 2 times n plus 1 over n plus 1. Well, when we look at the limit as n goes to infinity of that ratio, we get 2, which is bigger than 1. It's a nice question. And so that says the summation from n equal 1 to infinity of 2 times 4 times 6 all the way up to 2n, all divided by n factorial, that's going to diverge by the ratio test. And I think that's a pretty good stopping point for this video. And this is a video from it's the section on the ratio test in the calculus, in a Calculus 2 course. So, and we ended up doing 6 examples. Thank you.